Okay, so just to refresh before the break, we have covered basically the concept of center of gravity, center of mass, and centroid. We have go through some of the real applications where this is applicable, right? In terms of the vehicle, etc. We have covered about this one. What is the quantum of this? We also covered already the equation till this point, right? So just to refresh on the equation, if you still remember, so one thing, hopefully you still remember what is the difference between this one and this, right? So one is just the general x, y coordinates. This is this one. If you consider of the whole area, the centroid will be x bar, y bar. And then this one is for integration when you select one particular element. And take the element, the centroid is this one. Right? And just call it x wave, y wave. Right? So that's the difference, and in the equation you will see that it relates the x bar with the x wave there. Right? So the element and the whole area. Right? So in the equation we will have x bar equal to integration of x wave dA more integration of dA. This is for centroid with respect to area. If it's 3D with respect to volume, then d v. Right? So yz is just to change this y, and z of course. So center of mass, you just change area to mass, right? Etc. Centroid is weight, etc. Right? So if you memorize one and you understand, you can basically know what to do with y and z, and you know what to do with mass, weight, etc. Okay. Right. So that's the equation. The first thing is the equation. Hopefully, you still remember that. If you don't, then hopefully this refresh our memory. That's the equation, and then yeah, in the table at the back of your textbook, you will have something already given like this on the location. Right? It will give, like, for example, for triangle, if you look at the table, it will give 1/3h. So you know that one. In this case, it is exactly at the middle there, for example. Right. So in terms of the steps of calculation, so that basically 3 steps. One is you have to identify what is the element. What this means is either you have a horizontal element or vertical element. Right. What this means is actually if you have any area, you chop like this so that the element is horizontal. In this, if you have the area, you chop like this so that the element is vertical. That is what it means. Right? That's the first thing. Second, establish what is dA, x wave, y wave, right? Meaning for each element, what is dA of this one? So basically this multiplied by this one. Or for this one, area is this multiplied by this one. The area of rectangular basically. X wave of this, what is the coordinate of this one, right? The coordinate of centroid of the element itself. Right? Why do we need this? Because we want to plug in here, right? Once you have x, y, for example, you have y also with y. So you have this one and the A, or sorry, if you consider for, of course, this normally what we discuss is with respect to area, and if you have mass like this, then we change this to the M, of course, the A, the V, whatever that we have. So why do you want to determine this one? Because we want to plug into the equation so that we can calculate, right? So that's why we list this one, and then of course, after that you just plug into the equation for this one, and then of course you integrate, you get the solution. So that's basically the steps. It's just as simple as this. The important note is that you have to understand whichever choice that you have will give a different thing here, and it will give the different level of easiness or difficulty or short or long your calculation will be. Right? So that's why you have some hints here. For example, the first hint is if your equation is, for example, y equal to x squared plus 2x plus 1, for example, right? Can you express x in terms of y? It might be difficult to change this one, right? So this one is difficult. If that is the case, you are stuck with this one in a way. So which one do you have to choose? Is it this one or that one? The horizontal or vertical? Do you think? Do you understand the question? If for example, if you have whatever, and the equation is this one, y equal to x, 2x plus 1, for example, right? Now, the first step of calculating is you have to select whether this element or this element, horizontal or vertical. So if you are stuck with this one, meaning you want to express x in terms of y, you don't even know what to do. So which element should you choose? Vertical. Why? Because you have to understand, if this one you have dx here, this one you have dy, the difference, right? In this case, meaning you will have to integrate with respect to dx. In this one, you will have to integrate with respect to dy. Right? So if you have this gains and you need this one, you cannot. You will be stuck there, right? So from the beginning, you have to see what equation you have. So if this is the equation, then you have to have dx. Then I choose this one, so I choose this element. I divide like this. Then you have to be able to think like that. If your equation like this, x equal to y squared plus 2y plus 1, and you don't even know how to express y in terms of x, so I'm stuck with this one, so I will choose dy, meaning this element, because it will have an impact in terms of the limit, etc. Right. The meaning of this one is when you chop like this, the first element is here, the last element is here, right? So that will be the limit in terms of your integration. This one, the first element is here, the last element is here, so that will be the limit when you do the integration. Okay, that's the first thing, that's the first step, the first hint there, meaning which element you choose sometimes depend on the equation that you have. If you have simply just y equal to x squared, for example, then x is simply y half or something. So meaning either way it's not that difficult, so you are still open for both. Alright, so that's number one. Number two, express dA in terms of yes, okay, so this is the second step, and then third step, I'm combining this. You express also the x wave, y wave, and then express all variable. So yeah, make sure also if you have to integrate with respect to x, everything inside should be in x already. Yeah? Meaning if you have y something, you have to replace with whatever equivalent that you have in your question. Similarly, right? Before you integrate. Alright. So there's two how to say? There's two consideration when you have to choose this one. The first one is this one. Obviously this one rather will constrain you significantly, because if you cannot even express this or this, you cannot even calculate for this one, you cannot even use this one, because you cannot even put any integration there because you're stuck there. Similarly here, you cannot use this one, right? But if you could use both, sometimes when we do the example, we'll see that which one will be easier. Both will give the same answer, but one will be longer, one will be shorter. We'll try that one when we do the exercise, you will see that one. Alright, so let's take a look at an example. Now, as I mentioned, the exact example in the slides already solved in the recording that I've already put online. So you can refer there. So I'll change the example so that we have more examples that should be solved, right? Now, for this one exactly, you'll see the recording. But if I change the question like this, right? Meaning that the line is the same, meaning y equal to x cubed, but the area is here instead of here. That will be the question will be totally different, right? This is one, this is one. Okay. So if this is the case, right? So we need to find what is the centroid, which is something like that, right? X bar, y bar. What do you do first? Okay, first choose element, right? Now, in this particular case, in terms of this equation issue, is there any issue here? Or no issue? Meaning, are we restricted to horizontal or vertical, or we can use both? In this case, both, because if you want to express x, it's just y 1/3, right? So it's not, meaning this, the issue here is if you cannot even express, then you're stuck. In this case, okay, both is okay. But which one do you think is easier, horizontal or vertical? Horizontal or vertical? Vertical is easier. Okay. If you choose vertical, right? Okay. It means you chop like this, and one element is like this, right? Right. So if you take the element like that, right? Because we have chosen the element vertical. We have to express now dA. Before to express dA, what is this one? dx. What is this side? This side. Y. One ke Y. Y. Kenapa? Now, you have to understand this. Okay, again, x and y is what? You know the difference between the three, right? This one refer to what? Coordinate of a point on the line. This is your line, so it is here. X, y, meaning what? Meaning this is x, this is y, right? So is this y? What is this? This line. No, y is here. If this x, y, meaning x here, y here, right? What is this line? What is this line? 1 minus y. Because this is 1, this is y. This is 1 minus y. You understand? So, meaning dA is 1 minus y dx. Okay, this is where it gets interesting, because if you actually choose for this element, if you choose horizontal, then what will be, this one will be dy. What will be this length? Where is x? Where is the point? Point is here, right? X, y. What is the meaning? Meaning this is x, this is y, right? So what is this line? X. So dA will be x dy. Now, so the way you select an element, even though both are possible, you'll see that one will be easier to integrate, later on one will be can be more complicated. But this one is not that difficult. Okay. When we go to this one, the x wave, y wave, right? The center of this one. This one will be what? For this case, x wave will be this is x wave, y wave, right? This is one. X wave will be do you understand? Okay, this is the coordinate, right? What's the x coordinate here in relation to x coordinate here? Half. Meaning, if this is x, this is half of this. Do you understand? Okay, if I draw, right? This is x, y, and then you have this element, right? This x, y. Meaning this is x, right? This is x, right? X wave equal to what? X, right? Boleh, right? Boleh? Betul kan? Okay, it is this. If this is x wave, y wave, right? This is x, y, right? X wave equal to? Well, x is here, right? What is this one? X is 2, right? Boleh? Because if you fail here, then whatever the rest calculation will be totally wrong, because you will use this one in your equation, right? So make sure you understand. First, what is this? This means the coordinate there. This means the coordinate here, right? And then how to get that coordinate? You have to be able to visualize. This is the same length, right? The same x. The whole of this is the same x. The difference is y. This one is the same y, right? But the difference is x, right? In this case, this will be easy, right? What will be y with?
Y.
Y, right? It's the same height. In this case, okay, this is really interesting. What is y with?
Half. Y over y minus 2.
Y minus 1.
Y minus y over 2.
1 minus y. And can you check?
1 minus y over 2.
1 1 minus y over 2 semua. Ke sini. Like this. How do you get this?
Ya, koordinat dan juga
Coordinate mana?
y.
Ni. Okay. How many of you said it is like this? Okay, what are you doing here? You take half here, right?
Yes.
Is that the coordinate? Meaning you actually calculate this length, right? Coordinate should be here, right? So you have to plus
Y.
y, right? Faham ke? If you see this one, nampak tak ni? Because when you have this is 1 minus y, right? So half of this is 1 minus y over 2, meaning you half of this one. But that's not the coordinate of this one, right? The coordinate is from the axis. So the whole coordinate, you have to add this y. So y plus this half, right? If you solve this 1 over 2 minus y over 2 plus 2y over 2 becomes 1 over 2 minus plus y over 2, right? Or 1 plus y over 2 if you combine. Ni matematik lah ni. Kalau tak kerti buat ni balik sekolah. But you understand the concept? Okay, okay. In terms of this, there's two ways to understand. One is because normally many students they like to think, okay, this half of the whole length, and then you have to add this one. The other way to see this one is this one is a middle between this and this, right? Because when we have rectangular like this is at the center. Meaning it should be the average. You understand that? If you have at the middle of two value, you have the average. How do you calculate average? If this is 1, this is y. 1 plus y over 2, which is the same. I think this is easier to understand. I mean, easier to calculate. You just add average of the two value. But some students tak faham average atau tak pernah calculate macam ni, the answer will be the same. Right? Understand? Any question before we go? Because if you cannot get this one correct, whatever you're going to integrate will be wrong because you plug in this value here, x and y. So if your x and y here is wrong, then penat dia integrate lama-lama tu nanti. Right? So now we have established this second part, the a, x, y, x weight, y weight, right? So we have whatever that. The rest is just integration. Now, as you can see, the selection will affect a lot because this one, when you have equation like this, x will be integration of x with dA over dA. For y will be y with here, right? So you'll see that for y will be more interesting because you have y and dA, right? Meaning when you combine this one, your integration equation will be a bit more complex than this one will be quite simple. So we'll try to do this one first. Right, on this part here. Okay, we'll do this part first. If I have to solve for x, will be integration of x with dA over integration of dA. This is exactly the equation there. Now we want to plug in. Right? So for x wave here, you just plug in this thing. Right? Whatever you have written here, you plug into this x wave here. So integration x over 2 half x if I want to write it as that. And then dA is you just write this thing, right? X dy. Okay? We just plug in the thing, and then integration of dA is x dy. Okay? That's the first thing to do. What will be the limit?
1, 0.
In this case, it's quite simple, 1, 0, and 0. But where is this 0 and 1 come from? Okay, as we mentioned, when you chop like this, meaning this is the last element, right?
Yes.
This is the first, so 0 to 1. In the example in the slide, they always give the same 1 and 1, so it doesn't test your understanding. Because if you understand it wrong, you still get 1. But in the exam, normally they give different values, so that you will have to choose the right one. Right? So in this case, you chop like this, is from 0 to 1. So we will simplify this one. This will be integration of 0, half x squared dy over integration of x dy. Can we integrate?
Yes.
What do we have to do?
Change x.
We have to change into y first, right? What is the equation? What is the equation? This one, right? So x equal to y power of 1 over 3. So if you plug in here, what does it mean? X squared becomes y
2 over 3.
2 over 3 y. And then x is y 1 over 3 dy. So if you integrate this, you'll get y to the power of, still remember how to integrate?
5 over 3.
5 over 3. So 3 over 5 here, right?
Yes.
From 0 to 1. And then y power of
4 over 3.
4 over 3, meaning this is 3 over 4 into 1. So if you solve this one, basically this is 3 over 10 there, and then you have, if you have 1, then it's easy because whatever power you have is just 1. And then this is 3 over 4 times 1, right? So basically you get 4 over 10, 0.4 meter. Good? Any question? This is just mathematics. If you already, meaning if you forgot how to integrate, make sure you revise. Okay? That's for x. X bar. Any question? Anyway, what about y bar? Now we are answering for this first, right? Before we go to here, which is because initially you choose to do this one, right? And choose the easy one first. Y bar will be integration of y with dA of dA. So you just plug in. So y equal to y with, so integration of y, dA is x dy over integration of x dy, right? This is just plug in. What will be the limit?
Limit 0.
Y is 0, 1?
Yes.
It's the same thing, right? Now, that if you understand that, it's straightforward. The limit here and the limit here doesn't change because we still chop like this.
Yeah.
Even though we calculate x or y or whatever, the limit is integration doesn't relate to this one. It relates to how you cut off your area, because this is the first, this is the last. You chop like this. Alright? Now, so we have to change to y. So x here will be y 1 over 3. So y multiplied by 1 over 3 becomes 4 over 3, is it? Okay, make sure you are able to deal with the fraction power fraction, right? Meaning, and did you know how to get this here? From here? This is y 1 over 3, this is y. When you get 3 over 3, 4 over 3, right? So when you integrate this one, you'll get y.
Y 7 over 3.
7, 3, so 3 over 7 here. 1 y
4 over
already, so 3 over 4 here. So this is 3 over 7 times 1 to the power of whatever, 3 over 4 of 1. So you are lucky if this is 1, so because that's why the slide we always use 1 because it's easy. If you have 2, then you have to calculate what over 2 power, blah blah blah, right? So this one, you get 4 over 7 or equal to something, I think. So the coordinate will be, yeah, this will be somewhere there, right? If this is 1, it is 0.4, meaning somewhere here, and then 4 over 7 is 0.6, something like that, right? So just to check, is it logical? It should be okay, right? I mean, that's another thing that you should be able to do. Just check. If you suddenly get somewhere here, okay, this is, okay, again, for, I'm not sure if there's any comma. We are doing not this one, but the area is here. Right, the area is here. So that's why it's here, right? If you have this, if you calculate this one, it should be here, right? So you should be able to check. Alright, any question with this first attempt before we go to this one? This is if you use horizontal. So now you can see that for this area, it's easier to use horizontal than this one, right? But for this one, which element do you think is easier? Vertical, right? Why? Because vertical, then it will be simply just this is y. But horizontal, then you have to this minus this or whatever, it will come something like this. So that's the effect in terms of which element you choose. Right? Okay, and for this one, I've also I think show both way in the recording. If you want to see, you can check the recording. Now, so we'll keep the answer first. So basically, we get 0.4 or from 4 over 10, and then 4 over 7, right? The answer. Let's see if this will give the same answer. It should, but let's check. Okay. We'll do x1 first. This one will be easier. If you have to use, so the equation will be the same. Right? So x squared will be x. So integration x. dA will be 1 minus 1 dx. 1 minus y dx over integration of 1 minus y dx. Right? And y you have to change to x with this one. Okay, what will be the limit? 0 to 1 because, but it's not the same as that one, it's because this is the first, this is the last, which is 0 and 1. Right? So if you expand this one, x times 1 x, and y is x power of 3, so x power of 4 dx. Now you don't have to do in one step. If you want to be safe, you do one by one, especially in the exam. Right? It's not, sometimes it's not worth to save space if you are exposed to error, right? So make sure you do as safe as possible. But because this whiteboard is limited space, 1 minus x cubed dx, right? Okay, so you can integrate. You have x squared over 2 minus x power 5 over 5, 0, 1 over x minus x power 4 over 4 into 1. So you have, you plug in, you have 1 over 2 minus 1 over 5 over 1 minus 1 over 4. What will be this one? This one will be what? 5 over 10 minus 2 over 10. 3 over 10. It's easier to do with calculator, right? This one will be 3 over 4. So you get 4 over 10, which is exactly the same. Alright. Any question? Obviously, for this one, it's not difficult though. It's just a bit more calculation. Right? And because we are lucky because the equation is simple like this. If y equal to x plus plus plus, then yeah, it will become, for this y become blah blah blah, and then multiply, so it will become expanded. Right? Okay?
Yes.
Okay, let's try to do for y. For y, integration of y will be a, integration of dA. So you plug in y over here, so that's the case. Let's do this one. 1 plus y over 2, right? So integration, if I take half outside, 1 plus y. And then dA is 1 minus y dx. Right? Integration of 1 minus y dx. Again, the limit is the same because we chop like that, right? 0 to 1. So if you spend this one first, 0, 1, half outside, so 1 minus y squared, is it? Dx 0, 1 minus y dx. If you bring it here, if I take a half outside, right? So integration 1 minus y squared, it becomes y equal to s cubed, y squared becomes x power 6. X of 6 dx. Integration of 1 minus x power p dx. So if you integrate this one, you get x minus x power 7 over 7 1 x minus x over 4 1 okay, half outside, so you have 1 minus 1 over 7 over 1 minus 1 over 4. Okay, so this one become what? 6 over 7, 1 over 2, 6 over 7 over 3 over 4. This will be what? 3 over 7 over 3 over 4. This is 4 over 7 will be the same. Right. So we have shown that both elements will give you the same answer, just that one will be easier and shorter than the other. Right. And yeah, when your equation is more complex than this, normally this will be more complex. Huh? When you have something like this and this is more expanded, right? So if you have enough, generally speaking, if you have area like this is easier. If you have the area here, this is easier, generally speaking. But in the exam, sometimes they want to make it difficult. Both ways they will give you something like that. So this way or that way is still the same, right? So please try to find this kind of question, because in the slide they don't give that kind of question because they might look easy, but in the exam you will not get as easy as this. Okay, is it clear? This is we have run two examples simultaneously. One is a question example, but two solutions simultaneously, which give the same answer, but yeah, because in the end you have to know both ways. Because sometimes the question is easier like this, sometimes the question is easier that way. Meaning you have to understand how to get this for both elements. Any question? Alright. So move forward. Alright. Now taking a look at the example here. Now this example, actually if you see the question in the slide, it doesn't even ask you to calculate until the end. It just asks what is the A and X with and Y with, right? Just to see if you are able to get that. Okay, for this case, if okay, because for exercise we'll do both, right? If you take this example, but you take take the easy one. If you take vertical element, right? So the A will be what? Okay, but what is this one? This is the x, but this is right? Y. So y, yeah. What is x wave? For this one? Can you imagine? X. Okay. Was this and this have the same x, right? Y wave? Macam mana cakap tadi? Y over 2, right? Okay. This is y. This is y over 2 half. Okay? Okay, that's settled. What if I choose this one? So this will be
D1
dy. Okay, in this case this is 1 meter. Right? What will be this length?
1 minus 1 minus
I mean x. Everyone understand why you get this? Because this is x, this is 1, so this is 1 minus x, right? So dA is 1 minus x, y. What about x wave?
x wave is average.
Okay, if you take average, average between
1 plus
between 1 and x, right? 1 plus x
over
Divided by
2.
2.
Y wave,
Y wave is y.
y, right? It's the same level. Alright, if I change the area, so meaning this area, now is this area, right? If I change the area there, here, right? This one, right? So if I use horizontal, this will be dy. What is this length? What is x? So dA is dy. Next wave,
X wave is x
X
minus 2.
x minus 2
Divided by 2.
Divided by
x over 2.
Ah,
Y wave,
y wave is y.
alright. If I use vertical, this is the x. What will we do this one? If this is 1,
1 minus y.
y. So dA is 1 minus y dx. Next wave,
X.
x.
Yes.
Y wave,
Y wave is average 1 plus y over 2.
alright. So if you understand this, then it's okay. Right. Okay, what about, okay, that's because I mentioned already, right? What about in this way? When you have this one, what do you have?
This one is
Okay. Because in this case, you have to label the equation. This is equation 1, for example. This is equation 2.
yes.
So this will be x1, y1. This will be x2, y2, right? So if you have this one will be the x. What will be this height?
Then is y 2 minus y1.
Okay. So the a will be y2 minus y1. X, right? X wave.
X wave is x.
So this is x, right? Because it will be equal to x1, equal to x2, equal to x, meaning it's the same x or something, right? What about y wave?
y2 plus y1.
y2 plus y1 equal to, how do you get this? It's the average, right? Okay. So as long as you understand the concept, then if you want to use horizontal, then you know what to do, right? This one is actually because it wait. Mana dah? Because when here, okay, this one, okay, it's understood, right? This one becomes easy because it's actually all minus 0. This one is minus, meaning if you have two value, then you have to minus like this, for example, right? This one is actually x minus 0, right? X minus 0, for example, to put in context. Okay, is it understood? Alright. So, you understand this one. Alright. Okay, the question. Oh, I got a question. the first question first. We have steel plate. Okay, if you look at this one, it is actually from previous chapter that we have covered, right? Where we have roller, we have pin, right? So if you have to solve this one, steel plate, we know the weight, we know it is non-uniform thickness, meaning the thickness is different, and density supported by shore. Okay, if we want to solve this one in previous chapter, meaning we have to draw the free body diagram, which of these do we need? Do we need center of gravity or center of centroid? We need center of gravity, right? Okay, is it center of gravity and centroid? Is it at the same location or not?
No.
Why not? Based on this question, when is it the same and when is it not? The location of center of gravity and centroid. You still remember the example of the bus? When is it? Meaning, because centroid is here, right? Center of gravity can be lower, right?
Yes.
Why is it different? When is it different? And when it will be center of gravity is here also?
Because
If the density is the same, etc., right? I mean the weight distribution is the same. Like it's a block of wood, then center of gravity will be there, right? But if you have the engine weight is here, etc., it will bring it down, right? So in this case, if you have thickness is not the same, non-uniform is the same, right? Density is not the same, then it will be different. If it's the same material, same thickness, then it will be the same, right? Okay, if you want to do this one, okay, never mind. We'll go to this one. But this example also already covered in the recording, so you can take a look at the recording, right? So we'll change the question a bit if we shift the shape around. If we shift the shape around, meaning if we make it let's say I make it like this. Wait, I can shift mana? Let's make this bigger then. This one is more bigger. And then we have a ruler here, for example. Right. One, two. Okay. Tak, kalau ni kat sini tak susah ni. Kalau sini 2, sini 2 eh. 4, 8. Okay. So if I make this one y equal to minus half x. Okay.
Ganti ke x sama ni.
So kalau 8 dia berapa?
Tinggi dia 8.
Betul. 16 ya? Negatif. Okay, kalau masuk 16, 8 kan? Okay. Let's say it like this, right? If you have to solve what is force at the pin and roller, meaning eventually you have to draw x, y here, force here, and where's the weight here, right? But the question is where to put this weight? Is it here, or right? So that is where we have to find the center of gravity. To make it easy, for example, this way is also to make it easy. The steel plate is this thickness, meaning the thickness is the same, and the density is the same. So meaning the centroid and center of gravity is the same. So we can just use this one. We don't need to use this one.
Yes.
Right. Okay. So how? Okay. In this case, how to calculate? Meaning what we need is this one. How to calculate this? Okay. Which element? Horizontal or vertical? Because the first step is select the element.
Yes.
Horizontal or vertical?
Horizontal.
Okay. In this case, okay, this is a bit different than this one, right? Okay, if we go to this one first, the solution is in the slide, but in the recording. But if you understand, if you take horizontal, the issue is, meaning because when you describe what is this length, right, you use these 2 points.
Yes.
But this equation is valid throughout, but this equation is only valid here. You cannot go up there, because up here, the equation here is different than the equation here. So you cannot integrate from the beginning until the end. You have to become 2 parts, and we haven't learned how to combine 2 parts. But if you do this element, then this and this is valid from the beginning until the end. You understand? Meaning the point here is the same line, the point here is the same line from beginning until the end of the whole area. So that's why you have to use this. For this one, which element do you have to use? Horizontal line. Because this point will be valid throughout, meaning from, if you chop like this, meaning the first element is here, the last here, right? From the first to the last, the point is valid, this point is also valid. If you use vertical, then it's only valid until here, because this one, the equation already changed. Alright. So that is also a condition where you are stuck with one. You cannot choose the other. Until we learn the next subchapter where we can do separately and then combine later. Right? But that will make it dua kerja lah. Right? But kalau dia tak kerti nak buat benda ni, tu masalah buat dua kerja tu. The answer will be the same. But anyway, so we'll do this one. So in this case, horizontal. This will be you understand why is dy and dx, right? Because this is x, this is y, right? What is this length? Okay, you have to label. We label this 1, we label this 2, this line. Meaning y1 equal to half minus half x1. And then this will be x1 y1. This will be x2 y2, right? If you label that level. So in this case,
x1 plus x2.
X2 minus x1.
x2 y.
And x2 minus x1, right? This minus this. Do not be confused by the location, because then the negative will come in and it will be, you will add the two values, but do not put plus, because fundamentally is when you have two coordinates, that minus that, you get the length, right? So in this case, dA will be x2 minus x1 dy. What about x wave? Average means x2 plus x1 over 2. Y wave? It's the same y drop, right? Up to this point, any question? Because if you get this, then you can integrate. But of course, you'll see that, okay, because you have to change this into y, and that is why you include these things. This is still easy because we do not have plus something, because it's go to the origin, right? Nak bagi susah sikit? Tak boleh. Because you have to know how to deal with when, for example, 2x plus, right? Then macam nak buat tu. But anyway, we already set this question. So for buat senang dulu lah, y bar. Y senang ni sebab dia y lah, yang ni kita baca. Okay, so integration of y wave dA is x2 minus x1 x2 minus x1 dy over integration of x2 minus x1 dy. This is just straight away plug in y and dA. Any question there? Understood? What is the limit?
2 to 60.
Huh?
2 to 60.
2 negative 60. 2 negative 60. 0, 8. Okay, how do you determine the limit? What's the question? Limit is from where is the first element, where is the last, right?
Yes.
You understand the concept? Where is the first element?
1.
1, 1 pula ni. You understand if you take this element, what do you do? Actually you chop like this, right? Where is the first element? This one, right? The last element is this one. You understand the concept?
Yes.
Because if you put the wrong limit, then the calculation will be wrong when you plug in the limit, right? So 0 to 8. Okay. Understand? It depends on how you chop your array. So, so you have to change into y. So in this case, okay, we have to choose x into y. Eh? So in here x is okay, y over 2 square root.
Yes.
Okay. Kan? Yes. 2 square. Or y2 of half over square root of 2. Now, I will have a habit to separate this thing. Meaning y square root and square root 2. So that when you want to integrate, you do not confuse. Because if this is together, when you integrate, sometimes you forget that this 2 is a number on its own, right? If you do like this, you don't forget. This one, x equal to minus 2y. So again, this is x1, y1, and but again, y will be the same because y is the same. Right? So this is x2, this is x1. So, ini dah dulu lah. Y is y lah. Y, okay, yeah. Okay, initially is integration of y with the integration of a, and then it become just y, right? Because y is equal to y. So, x2 is, okay, if we do one by one, so 8, y, so x2 is, this one. So y power of half over square root of 2, and then minus x1 is minus, so it becomes plus 2y. Correct? Okay? Because x1 is minus 2y, so minus, okay, 0, 8, x2 is y half over square root of 2 minus jadi plus 2y. Alright. So if you expand this one first, division of 8, what do you get then? Y to the power of 3 over 2 plus 2y square. Division 0, 8 1 over square root of 2 y, ini tak dengan sama je lah, plus 2y. Solving integration, so 1 over square root of 2, integrate this one y,
5 over
2, so 2 over 5, alright, minus plus 2y cube over 3 from 0 to 8. Oh, memang guna calculator ni. Okay, and then this one will be 1 over square root of 2 y 3 over 2, so 2 over 3 here plus 2y square over 2, and the rest is mathematics. You can solve the rest, right? And check whether it makes sense in this particular case, right? It should be within this one because this is calculating for y, right? If it's somewhere here, not logical, somewhere there, it's not logical, right? And it should be logically it should be upper half, right? If this is the shape. So that's how we check. So you can continue. Any question here before we try for this one? For this one. That's where it gets more interesting. It's just interesting about the calculation. The statics part is already settled because this is mathematical integration, right? Termasuk ini. Okay. Alright, so what about x? So if you want to do x, integration of x with dA or integration of dA. So x is if I take half outside, so x2 plus x1, but dA is x2 minus x1 dy over of x2 minus x1 dy. Now there's a reason why I already have a habit of writing like this, x2 minus x1, because when you do the averages, you can say x1 plus x2 over 2 or x2 plus x1 over 2, right? But if you have a habit already, you want to, because this one you straight away know how to, right? But if you, sometimes students get confused when they have just the arrangement is different, then they got stuck, right? So that comes with practice. Okay, what is the limit?
Delta
0 to A, right? It should be the same because we are chopping the same way. It doesn't change the element. So integration 0 8 becomes x2 square minus x1 square dy. x2 minus x1. So we have to change into y, right? So if we take half outside, x2 square, this square becomes y over 2, right? Minus x1 square, minus 4y square, plus or minus? Minus, right? Because when you square the whole thing becomes plus there, right? Dy over 0 8. This one should be exactly just like that before, right? Plus 2y dy. And when you integrate, so this becomes something y square over 4 now, 4 y cubed over 3 0 8. This one is the same as before, right? 1 over square root of 2 y y 3 over 3 plus 2y cubed over 3 right? That's good. Now, this is just for the coordinate, right? And if you calculate, you should get. Okay. Do you think you get positive or negative here? This one is obviously positive. This one, do you think positive or negative?
Negative.
Because when we plug in, this will be higher, right? It will be negative. So it will be somewhere here. So it's logical. Right? You should reflect. Especially if this shape is more here, so it's not here. Right? So you'll get something negative here. Of course, this one you don't have the answer because I just created the question just now, right?
Yeah.
For this one, you have the recording and you have also the slide. Now, but that is not the end of the question, right? Because you only, what we show just now is just to determine this one. Meaning you can draw. Okay, it's here, so you draw the weight. The question is, the weight equal to what? If you take the same density here, the density is given 7850 kilogram per meter cube, right? How to get in terms of Newton? So from here you should know that if you can multiply by something meter cube, which is the volume, you can get into kilogram and then multiply by Newton, gravity. How to get the volume? How to get the volume of this thing? Okay, if thickness is given, thickness meaning thickness is given, right? So you have to get the area, right? Meaning area times thickness. Thickness is given. How to get the area?
From the x times y.
Okay, if you understand this one, this equal to what? Area, right?
Yes.
So you just take this one. So the best is if you do not mix until the end. If you already mix, then meaning how you bring down, then that's already different. Meaning it's no longer this one, right? You already combine, right? But if you do separately until the end, only you divide or whatever, this is already area lah. Because A is integration of dA, right? And if you do both for x and y, this portion will be the same, right? You can check. And you just take that area, meter square, times the thickness meter, and then you can calculate. And then you get the free body diagram, and then summation of Fs, summation of Fy, summation of moment, as we have done before. Okay. So I think we are running out of time. Another 8 minutes. So any question here? So those are the questions. Okay. This example is quite good in the sense that it shows the possibility that the exam question can combine chapter. Meaning that even if you know how to calculate this one, right? But you do not know how to integrate, then you're stuck. Because you cannot even locate where is the location. Without that location, you cannot calculate moment. Right, so, yeah, that's a possibility. And even though, I know this chapter, this is chapter 5, isn't it? But if you do not know how to solve chapter 9, then you are stuck there. Right? So, make sure you are not those sad story that happen in exam. Alright. Okay. So for this slide, we already show in this. If you want to see the exact slide discussion, but even in the recording, I do not cover until this one because I do not have the time. But as long as you know where is the location and x, y, and the width, the rest is what we have covered before. Okay, that's the end of this part. The 9.1, which is how to calculate how to determine the location of centroid. No, okay. Normally, in terms of the integration, it's always area, because volume is too normally it's quite difficult for you to integrate, so we don't test it that much. And this one is also normally it can be quite confusing. So normally integration will be mostly in area. But when we cover 9.2 later on, when we do composite without the need of integration, we can have volume, mass, weight, etc. So that's one thing.